Hello and welcome to Math 200 Online Statistics at Cañada College. My name is Lapuz. In this video we will do a homework problem from section 6.3. It said that a survey found that women's heights are normally distributed with a mean of 63.7 and a standard deviation of 2.5. The survey also found that men's heights are normally distributed, and that has a mean of 67.9 and a standard deviation of 2.7. And they want us to answer the questions below. Let's just take a screenshot of this and take it to our Google Sheets so that we can do our work while we are looking at this problem. Let's just shrink that so we can see it in a page. And for this, it might be useful to make up a table. We have information about women's heights and men's heights. They gave us the mean and standard deviation. And for the women, the mean was 63.7. The standard deviation was 2.5. For the men's, the mean was 67.9 and the standard deviation was 2.7. You don't need to make this table. I just kind of created this table to make it easy to navigate through our Google Sheets and the commands that we're going to need. Now, if you recall, we're essentially looking for the percentage of women that fall within this range. And if you were to draw a bell curve, we're essentially looking for the area under the bell curve. So the command that we want is going to be NORM DIST. This will take in an X value and a mean and a standard deviation, and it's going to ask if this is a cumulative calculation, and in our case it will be because we're looking for the area, and so we're going to make sure that we're going to put true for the cumulative part. Now the question is asking us to find the minimum height requirement is 4.9 and the maximum is 6.3. So let's make a note of that, our minimum and our maximum. The minimum requirement is 4 feet 9 inches, and so converting that into inches, 4 feet is 48 inches plus 9 inches is 57, and our maximum is 6.3. 6 feet is 72 inches plus 3 makes 75. So these are our minimum and maximum values. We want to find the area in between these two values, and this normal distribution function only finds the area to the left. So we will need to break this down a little bit more, and we will take a look at the work that we do for women. And to answer this question, we need the area to the left of 75 inches. We want to find the area to the left of 57 inches. And then we're going to subtract to get the area between 57 and 75. So for women, to find that area, we're gonna say equals NORM DIST. That's the normal distribution. For the women, the area to the left of 75, we'll just either type 75, or since I have these values already, I'm just going to use the power of spreadsheets and click on those cells. The mean for women is 63.7. and the standard deviation for women is 2.5. And remember, we want this to be true. And then that value is 0.9999. So that's almost the whole thing. Area to the left of 5.7. We will need to type our equals and norm dist, normal distribution. And this time we're looking at the area to the left of 57. So I'll type 57, or I'll click on the 57 box. The mean and the standard deviation, and cumulative is true. And now I have that value. The difference is going to be the big value minus the smaller value, and I get 0.9963. So this value is 0.9963. We can make this into a percentage, and then we'll see how much we need to round off. So right now it's 99.63. We'll check our answer, round off to 2 decimal places, 99.63, and they already have the percent symbol there. Now the next part, they want us to find a percentage of men meeting the same requirements. And so we're essentially going to want to do the same thing here, except we're going to want to find the statistics for men. Our values or our commands will be the same. So I'll say equals norm dist, and then we'll start off the area to the left of 75. So again, we can type 75, or we can just click on 75. This time the mean for men is 67.9, and the standard deviation for men is 2.7. So I'm clicking on those cells, and remember to type in true. And I got something similar, a little bit less than the women's answer. And now let's fill this in with the area to the left of 57. So equals norm dist, and this time it's 57. The mean for the men is 67.9. The standard deviation is 2.7, and then true. And now the difference. So those values subtracted, and I get 0.9956. If you want to round that off to 4 decimal places, it's 0.9957. Of course, if we have it do the decimal, it does the rounding for us. 99.57. Now the last question is asking us to change the height requirement so that we exclude the tallest 5% of the men and the shortest 5% of the women. For this, we need to use the inverse norm, because now you're looking for the x values. Instead of looking for the areas or the probabilities or the percentages, you're looking for x values. So let's start off with the tallest 5% of men. So let's just label this tallest 5%. To find the tallest 5%, we're going to want to identify the area on the left. When I think of tallest 5%, I think of shading in the right side, because the right side is where the taller people are, and the left side are the shorter people. So the tallest 5% area on the left is 0.95. So it's the complement, or the difference from 100%. The inverse norm function, if you remember, takes in the area to the left. So let's review the inverse norm function. If you ever have a question about these statistical functions, you can always search the function menu and look for statistics in this case. And these are all dealing with the normal distribution. So it's the normal distribution, and in this case it's the inverse normal. And the inverse normal is looking for the x, the mean, and standard deviation. And then it's going to give you the x that you put in is the area on the left side, the cumulative area. Okay. So it's going to be the normal inverse function. And then area to the left, mean, and standard deviation. So those are the inputs. Now that we've established that for men, the tallest men, the area to the left is going to be 0.95, we're going to go ahead and do the norm INV and then 0.95. We need to input the mean for the men and the standard deviation for the men. So we have that typed up already, so I'm just going to click on the cells for the mean and the standard deviation. And it looks like instead of 75 inches, it should be 72.3. And then the shortest, 5%. Since that's the area on the left already, then that's what we're going to input in our normal 5%. Oops, sorry, we're losing control of our keyboard here. Now our function is going to be norm INV again. This time the area to the left is 0.05, and then this time for the women the mean is 63.7 and the standard deviation is 2.5. So it looks like the minimum should be 59.58. So let's look at the problem again. The new height requirements is at least and at most. So the smaller value here is going to be 0.5958 or 59.58. Round to one decimal place. 59.58. Round off to one decimal place would make this into a 6. And then at most, the larger value is going to be 72.3. Okay, let's check our answer. And that looks good. I hope that helps.